Okay, so the next section talks about the abstract class, if I can get back to that. So the abstract class is a new class in that we cannot instantiate. I got to repeat this. We cannot instantiate directly from an abstract class. How we use abstract classes are it's a way for us to set up a template, so to speak, of how a class we need to work. And then when we inherit from that, we will extend from an abstract class. But you'll right here in the instruction it says no other classes can extend from it. An abstract method has no body and must be overridden in a subclass. So it has to be overridden. So I can have what's called an abstract method where I can say public abstract void set value. Now, this, you notice, it just has a semicolon at the end. There is no body to it. There's no code. So what we're saying is this is now a template. I'm forcing you to override this particular method. Now, you have to have an int coming in, and in this case, a void coming out. There's nothing coming back. So you have to basically override this. Okay. Now, you don't have to have abstract methods. We can also have what are called abstract classes. And classes we must extend from. So an abstract class is not instantiated, but other classes extend from it. And an abstract method has no body and must be overridden in a subclass. Okay, so here we have the student class. Let's go ahead and bring it up in the code. So, so here it is. We have a public abstract class student. Now if we look at the comments up here, it says the class student is an abstract class that holds general data about a student. Classes representing specific types of students should inherit from this class. So think of the student class, which is abstract, as kind of the generic student. We need to create a specific student, maybe for the engineering department or for the math department or for the English department. So we would create specific students specific to that department, and we will extend from this class. Now the great thing is about abstract classes is they have concrete methods. So if I look down here, I have a toString, which is kind of a concrete class, but it's extended from the object class. But here we basically have string str, so we create a string variable, and then I say string is equal to name, boom, boom, boom. So I can actually do that. Then okay, we'll talk about that in a sec. Here I have a constructor student. So this constructor can be used by the method or the classes that inherit from here. Down here, I'm telling it, if you're going to use this class, you have to create a get remaining hours method. Now, how you code it is up to you for your class, but I'm passing nothing in. I'm receiving nothing, and I have to return an int. Okay, so that's basically the rule. You have to create this method, and you're getting nothing into it, and you're returning an int. Okay, so this class is already written for us. These instance variables are already available to us. This particular method is available to us as well. We can actually execute it in our subclass, but we have to override this particular class. So I believe, well, let me go back to it's the comp science student. Okay, so we go back over here to the comp sci. So here it is. So here's the comp sci student, and it extends student. Okay. Now again, if we take a look at student, there we have name, ID number, and year admitted. Those are available to all subclasses. Over here, it looks like I've actually created 3 finals: math hours, CS hours, and gen ed hours. And then I've got Looks like some other instance variables. I got math hours, CS hours, and gen ed hours. So down here I've got a comp sci student, and I'm receiving a string and an int. And notice I've got super in ID and year. So I'm actually bringing in from the super, which is the class above, which is the student class, I'm bringing in the in ID and year. Oh, I'm sorry, name, ID, and year. So I now have access to the name, ID, and year again from the superclass. So I come down here and I've got my setter. I got my setter, and then I've got my getter. Now this one says get remaining hours. Now what is this? This is that abstract class that I have to override. Remember, I'm receiving nothing in, but I'm returning an int. So I'm forcing anybody who uses the student abstract class, you must rewrite this method. So I'm saying int regular hours and remaining hours, and regular hours are math plus CS plus gen ed, and remaining hours are regular hours minus math hours, CS hours, and gen ed hours. Okay, so these are the constants, the finals, and these are basically what's being passed in. And then I say return the remaining hours. Okay. So if we look at the demo, the comp sci demo, here I just create a comp sci student. Remember, this class is extended from the student abstract class. And I have a CS student, and it's a new student, Jennifer Haynes, and here is their ID number, and here's the year they admitted. And then CS student.get math hours to set set math hours, set the CS hours, and set the gen ed hours, and then I say go ahead and print the CS student, which is the to string, and then I have hours remaining is a CS student.get remaining hours, and that's the method we had to override. So if we run this, year admitted was 2004. The major is computer science. Math hours taken 12. Computer science hours taken 20. Gen ed hours taken 40. The remaining hours are 48. Okay, so pretty cool stuff. So some of those methods are in the superclass. We have access to them. Same way with the instance variables, and then we have an abstract method that we say we want you need to rewrite specific for your particular class. So neat stuff. Very, very powerful. The abstract class, very powerful. Abstract methods, powerful because we say we want you to create this class, but you need to write it your way. Write it how you need it for that particular class. Okay, so the next section is 10.9 interfaces. So we've seen abstract classes, and the great thing about abstract classes is they have concrete methods we can use. We also have abstract methods, and that's a whole nother subject, but we do have, so if we have, so we kind of saw this in the previous section. We have the grading, so all the methods in the superclass and even the sub-superclass, all the way down to the subclass, it has access to all those methods up above. Same thing with the abstract. Okay. Now, an interface specifies the behavior of a class. Now, what that means is I'm creating a contract that you have to abide by. And the thing about an interface is there basically is no code, none at all. So what does it do? Well, here we have, let's take a look at relatable. So here is relatable, and it says public interface relatable. Boolean equals graded activity G. Boolean is greater than graded activity G, and Boolean is less graded activity G. So apparently we're using some type of so here we have a class called graded activity, and it's going to be called G. Here we have another graded activity G, and we basically have these methods: equals, is greater, is less, all Boolean. what's going on there? Well, basically what we're saying is we're going to have a method called equals, is greater, is less, and it's going to return a Boolean. Where's the code? That's where an interface comes in. If you use this interface, you are signing a contract that you are going to create these three methods and return these variables, these data types, a Boolean, Boolean, and Boolean. Okay, so how the heck do we use it? Well, if we look, so in order for the class to use the interface, it must implement. So in the past, we've seen extends. So extends, we can extend one class to another class, and obviously an abstract class to another class. That's extends. When we use interfaces, we basically say implement. Okay, so in this case, I'm saying public class final exam 3 extends the graded activity. Okay, so I'm taking all of that information from the graded activity and I'm copying that in from that's now going to be my superclass, and then I'm going to say implements relatable. So now I've signed a contract. I have to include those three methods, and I have to return a Boolean for each one. Okay. So that's the great thing about an interface is I have set up a template and I want these things to be followed. I want you to create this method, this method, this method, this method. I'm not giving you any code. You need to write that code. So they're basically going to be, we'll call it overridden. So every single one of them will be overridden. So here's final exam 3. Let's take a look at final exam 3. And so here's final exam 3. It extends graded activity, so we have all of that information, and then implements relatable. So if we come down here, I had better see, here's equals, returning a Boolean. Here is greater, returning a Boolean. And here is less, returning a Boolean. And now watch, if I commented this out, notice, and if I save this, notice I get an error on a final exam 3. Why? I must add unimplemented methods. Because I'm basically using an implements here. Now I could do this, I could do that, and now I'm fine. Life is good. Why? Because I'm just extending grade activity. But I go ahead and do the implementation. Now I have an error because why? I signed a contract saying I'm going to create those three methods. And this method is not usable. And now we are. Okay. So interfaces, a great thing to use to make sure that we all have the same stuff. Making sure that, so again, when we are using classes that are similar, I want them to all have these methods. So I'm going to make them use interfaces. Okay. So now we have, here's the interface demo, and so here I have final exam 3, so here's exam 1, so I'm instantiating as a final exam. I'm sorry, it's final exam 3, which is again extended from graded activity and now from the interface, and I'm passing 120. Here's 130, and then I say exam.getScore, and then here I say exam 1 equals exam 2, so it's going to execute that method from the interface, and is greater than exam 2, again it will basically print that, and then it is less than. So here we are actually utilizing those three methods that were basically included in the interface. So if we go ahead and run this, we can see exam 1 is 80, exam 2 is 70, exam 1 score is the highest. Okay, so notice they aren't equal. It isn't the lowest, it was the highest. So basically only displayed this because this was the only if statement that was true. So interfaces, pretty good stuff there. Okay, I believe that's it for this particular chapter.